Okay, so you guys are going to have to let me know what you think of these. Let me know if I'm going too fast or if you'd rather go back to doing more notes in class. So let's give this a shot. The first set of notes we're going to try on video notes is the notes on interval notation and solving inequalities. And interval notation is where we're going to start first. Let me choose a color here. So we're going to start here with interval notation, and interval notation is just a different way of writing inequalities. We use brackets, and we call these right here closed brackets, and we call these right here open brackets. So these are closed, and these are open. And the closed brackets mean that we are going to include the numbers that are listed next to those closed brackets. So they're equivalent to the greater than or equal to symbol and the less than or equal to symbol. So for example, if I just said x was greater than or equal to 4, then the way that I would write that is my x values are going to start at 4, so I put a 4, and they're going to hit 4, so I put a square bracket next to the 4 because I'm going to actually include the 4, and they're going to keep on going all the way to infinity. So I put a comma, and then I put the infinity symbol. And I want you to notice this note right down here. Remember that a square bracket means that you're hitting the number or you're including the number. Infinity is so big you're never going to get there, so you can't ever hit it, so therefore you can't ever include it. There's always parentheses when you have infinity or negative infinity. So then when I want to do open brackets, so let's say that I said x was less than 2. Okay, I don't know where it paused recording, so this may be a little bit repetitive, but it keeps trying to download a different version of some software. So let's say that x was less than 2. So that means that all of the x values that are my solutions are going to go all the way down to negative infinity, comma, they're going to come all the way up to 2. So we always go low end to high end. Negative infinity, once again, always has to have parentheses because you can't ever get all the way down there to it. And then, because there's no equal sign right here with this 2, I'm going to use an open bracket there, or parentheses there as well. Okay, so that's just a different way of writing an interval of solutions to things. So if I wanted to express these intervals in terms of inequalities and then practice graphing them so that we can go back and forth between the two forms, this right here, and I'm just going to use x. They didn't specify a variable, but I, of course, always use x when I need to. So what this interval right here is saying is that x is greater than or equal to negative 2, because negative 2 was the low end of my interval, and it had a square bracket. So it's actually going to equal the number or hit the number. And then x is less than 5, because there was an open bracket right there at the 5. So on a number line, what that would look like, if this is, I guess, about where 0 would be. So there's negative 2, 1, 2, 3, 4, so there's 5. And so if I wanted to graph this, there would be two ways. Going with the way the other college algebra, I guess the book and the other teachers teach it, is they actually use the square bracket and the open bracket on the number line too. So if there was a square bracket at the negative 2, they would put a square bracket right there it would indicate it goes all the way down there and hits there. And then it comes all the way up to 5 with an open bracket. And so then they would shade everything in between there, which is fine. Okay, another way of doing it, which is also correct, and it's the way you guys would have done it in your earlier math classes, is instead of using the square bracket and the open bracket on the physical number line, what you would have done instead is, I'm just going to sketch this down here, is you would have put a solid dot at the negative 2, and you would have put an open circle at the 5 and shaded everything in between. Either way is correct. So it doesn't matter to me which notation you use or which way you write that. Okay? If you have a problem that goes all the way down to negative infinity or goes all the way up to positive infinity, then what you would do instead is you would just shade off the end of the number line and draw an arrow that tells me that it keeps on going. So let's say this is where 0 is. Here's 1, 2, 3. Okay, so then what you would do is you would come over here to 3 and you would use either an open circle, a hole, or you would use that open bracket, whichever way, and then you would shade all the way down to this end and just draw an arrow that indicates that it keeps on going down to negative infinity. Okay, and then this last one here, 0, 1, 2, 3, 4, 5, 6. And then just like before when you were placing numbers in the number line when we were categorizing numbers, 2/5 is not marked on this number line, so it's 0.4. So you're going to actually put a little hash mark right there and label it 2/5 so that it's apparent what number that is, because otherwise it's just some random number in between 0 and 1. Okay, and then you would use either solid dots at both ends because of the square brackets, or you would actually use square brackets. So a square bracket here and a square bracket here and shade everything in between, because everything between those numbers is included in your solution set. Okay, so remember, you don't have to use the square brackets. If you want to revert back to what you did in your earlier math classes, you could put a solid dot here and a solid dot here, because that means the same thing. Okay. Oh, and then these as inequalities, once again, if I'm just sticking with x, here x would just be less than 3. And here x would be greater than or equal to 2/5 and less than or equal to 6. So, sorry, I almost forgot those. Okay. So going in reverse then, it says write the solution set in set notation and interval notation. So once again, this is just until we get comfortable practicing going back and forth between the two forms. So you notice there's this extra arrowhead down here, which means the interval keeps on going. So it starts here at -2, keeps on going to the right forever. So in set notation, that would just be the inequality. It sounds weird, but set notation would just say x is greater than or equal to -2. And most of the time we just don't draw the set bars, the set brackets at the ends of that. So you would just say x is greater than or equal to -2. In interval notation, it's going to look pretty much just like it does on the number line. There's going to be a square bracket at -2, and then it's going to keep on going all the way to the end. So it's going to keep on going to infinity, which of course means parentheses or open bracket. Okay, so I want you guys to pause it for just a split second and try this second one for yourselves. And you can pause it at any point if I'm going too fast for you, because I want you guys to be able to keep up. I just don't want this to take too long. Okay, so hopefully you paused it. If not, you can pause it now and try the problem, but hopefully you paused it. And so what you would write as, so the set notation for this is -3 is, of course, the low end, but it's just less than x, and which is also less than or equal to 2. And remember that these set brackets at the end that I'm about to write, they're technically considered optional, but there's the set brackets. And then in interval notation, it's going to look just like that actual interval does. Open bracket at -3, comma, all the way up to +2, ending with a square bracket. Okay, so hopefully you're all doing okay with that so far. So when you solve an inequality, what you're going to do is you're going to use all the same steps that you would to solve any other equation, except that when you multiply or divide by a negative, that inequality symbol will flip. Otherwise, all the other rules are the same. Okay. So let's say I'm going to solve this inequality down here. Remember that those first two steps of solving can be summed up in one step, S, simplify. So I'm going to simplify this left side right here. I'm going to distribute that negative 5 through the parentheses and get negative 5x minus 10. And then, of course, there was already a minus 3 over there. And the 3x plus 11 is already a simplified side. So then on the left side, I just keep going. I'm going to combine my like terms, and I'm going to have negative 5x minus 13. And then this side is still 3x plus 11. And then the next steps for solving this inequality would be to start adding and subtracting stuff to move it from one side to the other. Now, if you want to avoid having to change signs, so if you want to avoid worrying about this step, then you want to do what I mentioned in class. You always want to move the x's to whatever side will make them positive. So I'm going to add the 5x to move it to this side. So I'll have negative 13 is less than 8x plus 11. And then I'm going to subtract the 11 to move it to the other side. So I'll have negative 24 is less than 8x. And by doing that, that means my last step, the multiplying and dividing step, I'm going to end up dividing by a positive number, so I don't have to worry about the inequality flipping. So x is greater than negative 3. Okay, so you notice that none of the little hash marks on the number line were labeled, so I'm going to put them anywhere. I usually try to center 0 as close as possible. So that would put negative 3 right here. And then because x is greater than negative 3, I can do either that open circle, that hole, or I can do that open bracket. Either way. And then it's just going to keep on going to infinity because it's every number that is greater than it. Okay? So in interval notation, this goes from negative 3, but it doesn't include it. This is what we call negative 3 non-inclusive, all the way to infinity. Okay? So remember, pause it at any point if you need to catch up, but I'm going to go ahead and keep on going. Okay? So what I want you guys to do is I want you to pause it right now, and then I want you to solve this inequality, and then I want you to write it in set notation. So that's as an inequality. Okay, hopefully you paused it. Okay, and you took a minute to solve it. And so I'm going to follow my SAM steps. So as I begin simplifying, I distribute that negative 6 through here, and I get minus 6x plus 30. And then this side I do need to simplify this time. So I distribute the 2 through there, and I get 14 minus 6x. And then I combine my like terms on both sides, so I'll have negative 6x plus 27 on this side. And on this side, I'll have negative 6x plus 15. Okay, and here's where you run into a problem, because when you go to the A step, you start adding and subtracting stuff to move it from side to side. And so what you try to do is you try to add the 6x to move it from one side to the other, and what ends up happening is it cancels off of both sides. And so what you're left with is this inequality, which doesn't make any sense. And there's a reason for that. I don't know if you guys remember, but when the variables cancel out, like when you're solving systems of equations and stuff, you're left with either a statement that's always true or a statement that's never true. And in this case, 27 is never less than or equal to 15. So this is what we would say no solution to. Now in set notation, what that means is that we have no answers. So the solution set would be the empty set, which was, we saw briefly last week. It's just the little set brackets with nothing in it. Okay, so that is our solution set, is the empty set. Okay, so one more, and You can fast forward through this if you think you've got it and you don't need the practice, or you can pause it and try it for yourself if you think you do need the practice. So I'm going to go ahead and once again do all my steps. So I distribute and get 9w minus 9. And then I distribute over here and get negative 10 plus 6w. And then I combine my like terms, and I get 6w minus 9. And I get 6w minus 9. And this time, when I start trying to move stuff from side to side and adding and subtracting stuff, I end up with this. Okay, now remember, what you're going to be left with is a solution set that gives you a statement that's always true or a statement that's never true. And this one is going to always be true. And that's because 0, because of that little equal sign right there, 0 is always equal to itself. Now if it had been 0 is just greater than 0, that would have been never true, because 0 is never bigger than itself, but it is always equal to itself. And so this is what we would call infinite solutions. Well, what that means is that all of the numbers are solutions to it. So in set notation, you would say that w is in between negative infinity and positive infinity. All solutions work on that one. Okay? So then the final comments for today are these types of notations that we use in between our intervals of solutions. This is the word or. It's called the union symbol, and you literally read it to yourself as the word or. So let's say that I did this. If I said x is less than 3 or x is greater than 5, then what that would look like on a number line is that any number from 3 down would work, or any number above 5 would work. So your solution set would include both intervals of numbers. Okay, but the intersection symbol here on the next row is the word and. And so what that means is that it's going to be the solutions that are only true for both things. It's their area of overlap. So if I said x was greater than 3 and less than 5, that means my x values have to make both things true. They've got to be numbers that are bigger than 3, and they've got to be numbers that are smaller than 5. And so what that would look like is it would just look like this. It'd be the numbers just in between 3 and 5. Okay, so when we, instead of doing whole intervals, because remember intervals include all the numbers, like down here there's 1.9, and then there's 0.4, and then there's negative 2.7. All those numbers, those ugly numbers, are included when you do a whole interval. Well, when your solution is just a list of numbers, a set of numbers, then you don't do any shading. You might draw a number line where you put some individual points, but you don't do any shading on your number line. So what we want to practice is we want to practice this right here, remember, is the symbol and. So we want to do the list of numbers that are inside of set B and inside of set C. So I'm going to do that. Here's B intersection C. Okay, and it's the set. So what I'm looking for is the numbers that occur in both lists. So B starts out with the number 2, which is also in C, so that gets included in the list. Okay, 4 is in B, and it's also in C, so it gets included in the list. But the other two numbers that are in B, 6 and 8, they aren't in list C, so they don't get included in the intersection. 2 and 4 are the only numbers that occur in both lists. Okay, but if I asked you for B or C, I want the list of numbers that show up in one set or in the other set. So if I look at my list, I look at these two lists together, B and C, and I'm compulsive, so I'm going to go in order from smallest to biggest. So the smallest number in either list is -4, then there's -2, then there's 0, then 2, 4, 6, 8. That's the list of numbers that occurs in either list or the other. Now, if they occur in both lists, you don't have to list them twice. 2 is a number that occurs in B and it occurs in C. Okay, so I'm not trying to tell you how many times the number occurs, just the fact that it does occur. Okay, so last time, you guys pause, you try that last problem. Okay, so hopefully you paused. So if we look at A and we want the intersection with set C, okay, so I'm going to look at this list and this list. Okay, -4 is in C, but it's not in A, so I'm not going to include that one. -3 is in A, but it's not in C, so I'm not going to include that one. -2 is in both lists, so I list that one. Okay, done with that one. -1 is in A, but it's not in C, so I don't include that one. 0 is in both lists. Okay. 1 is only in A, it's not in C. 2 is in both lists. And that's it. The other numbers in the lists only occur in one of them. So there's my intersection, my set of intersection. And then my set of union, A or C, is the set that includes all the numbers in both lists. So I'm going to erase this because they're all cluttered up. Okay, so I'm going to start at the smallest and work my way up. So -4 is in one of the lists, -3 is in one of the lists, -2 is in one of the lists, -1, 0, 1, 2, 3, and 4. And there's the list of all the numbers that occur in one list or the other. Okay? So we're going to try to keep our notes shorter than this normally, but this was a full 8 PowerPoint slides, so we're at 22 minutes, roughly. So hopefully we can keep them under 18 normally. So let me know what you guys think.